Hello friends. Example number 6. A hydrogen atom initially in the ground level absorbs a photon which excites it to the n is equals to 4 level. Determine the wavelength and frequency of photon. Right. So here in this example we have to find out the wavelength and the frequency. Right. Now we know that E is equals to HF and C is equals to lambda F. So we know the formula. To find out frequency we have to use formula E is equals to HF, and to find out the wavelength we know that C is equals to lambda F. Right. So first of all, to find out the wavelength we have to find out the frequency. And to find out the frequency we have to use formula E is equals to HF, right? But here first of all, hydrogen atom initially in the ground level, and after that it absorbs a photon and excites to the n is equals to 4 level. So here due to this energy change, because we know that the energy varies with the various state, or we can say orbits, right? So to find out the frequency, first of all we have to find out the difference in energy, because in initial condition hydrogen in the ground level, and after that it absorbs a photon and excites to the n is equals to 4 level. So to find out the energy in the different orbit, we know the formula En is equals to minus 13.6 upon n square, right? So we know that energy of electron in nth orbit En is equals to minus 13.6 upon n square electron volt, right? So first of all, the hydrogen atom initially in the ground level, so for ground level we have to put n is equals to 1. So E1 is equals to minus 13.6 upon N1, so 1 square EV. So in initial condition the energy is minus 13.6 electron volt, right? Now due to excitation we have to find out E4, right? So E4 is equals to minus 13.6 upon n square, so 4 square. So minus 13.6 upon 16. So we get E4 is equals to minus 0.85 electron volt, right? So in the ground level the energy is minus 13.6 electron volt, and in n is equals to 4th level energy is minus 0.85 electron volt. So to find out the difference in energy we have to subtract E1 from E4. So difference in energy, so the difference in energy given by delta E. So delta E is equals to E4 minus E1. So E4 minus 0.85 minus E1, so minus 13.6. So we get delta E is equals to 12.75 electron volt, right? So the difference in energy delta E is equals to 12.75 electron volt. Now we have to find out the frequency. So to find out the frequency we have to use formula E is equals to HF, right? But instead of E we have to write here delta E. So delta E is equals to HF. So F is equals to delta E upon H. But here the energy is in electron volt. So first of all we have to convert electron volt into joule. So delta is equals to 12.75 eV and we have to convert into joule. So into 1.6 into 10 raised to minus 90 upon value of H 6.625 into 10 raised to minus 34, right? So we get F is equals to 3.1 into 10 raised to 15 hertz. So the frequency is 3.1 into 10 raised to 15 hertz. Now to find out the wavelength, we know the formula C is equals to lambda F, and we know C is equals to 3 into 10 raised to 8 and F 3.1 into 10 raised to 15. So now we have to use C is equals to lambda F. So now C is equals to lambda F. So lambda is equals to C by F. Value of C 3 into 10 raised to 8 and value of F 3.1 into 10 raised to 15. So we get lambda is equals to 0.9 into 10 raised to minus 7 meter, right? Okay, again see here. A hydrogen atom initially in the ground level, so N is equals to 1. Now after that it absorbs a photon which excites it to the N is equals to 4 level. So here the transition from N is equals to 1 to N is equals to 4. So determine the wavelength and frequency of photon. So to find out the wavelength and frequency, we know the formula to find out the frequency E is equals to HF. But here there will be a transition from N is equals to 1 to N is equals to 4. So here there will be a change in energy. So first of all we have to find out the energy in different level. So first of all for N is equals to 1, we know that the energy of electron in nth orbit En is equals to minus 13.6 upon n square eV. So for n is equals to 1, E1 is equals to minus 13.6 upon n square, that means 1 whole square eV. So energy is minus 13.6 eV. Now for n is equals to 4, we have to put the value of n is equals to 4. So E4 is equals to minus 13.6 upon 4 square. So we get E4 is equals to minus 0.85. So difference is in energy. Delta E is equals to E4 minus E1. So E4 minus 0.85 minus 13.6. So we get delta E 12.75 eV. Now to find out frequency, delta E is equals to HF. So F delta E by H. So we get frequency 3.1 into 10 raised to 15 hertz. Now to find out the wavelength, we know the formula C is equals to lambda F. So lambda is equals to C by F. So we get lambda is equals to 0.9 into 10 raised to minus 7. Okay. Now example number 9. A 12.5 electron volt electron beam is used to bombard gaseous hydrogen at room temperature. What series of wavelengths will be emitted? Now here a 12.5 electron volt electron beam is used to bombard the gaseous hydrogen at room temperature, right? So here again the energy will be changed, because we know that in ground state the energy of hydrogen gas has at room temperature is minus 13.6 electron volt, and here we bombard it, so the energy is 12.5 electron volt, right? So the energy becomes minus 13.6 plus 12.5 electron volt, which is the remaining. So first of all, the ground state energy of hydrogen at room temperature is equals to minus 13.6 eV, right? Now here a 12.5 electron volt electron beam is used to bombard, right? So here the energy beam is used to bombard the gaseous hydrogen. So here the energy beam is used to bombard the gaseous hydrogen, then its energy becomes minus 13.6 plus 12.5, so the energy is minus 1.1 electron volt, right? So to find out the series of wavelength, we have to find out the value of n, right? So again we use the formula of energy in nth orbit to find out the value of n. So energy in nth orbit, we know the formula, En is equals to minus 13.6 upon n square electron volt. So n square is equals to minus 13.6 upon En electron volt. So minus 13.6 eV upon value of En is minus 1.1 eV. So here eV cancel, so we get 13.6 upon 1.1. So we get n square is equals to 12.36. So we get n is equals to 3.51. So we can take n is equals to 3, right? So here possible orbits are n is equals to 3, right? Again see here the energy beam is used to bombard the gaseous hydrogen, right? The energy is 12.5 eV, so the remaining energy is minus 13.6 plus 12.5, so the remaining energy is minus 1.1 eV. So to find out the wavelengths, we have to find out the value of n. So to find out the value of n, we use the energy in the nth orbit. So we know that energy in the nth orbit, En is equals to minus 13.6 upon n square eV. So to find out the value of n, we formulate n square. So n square is equals to minus 13.6 upon En. So we get n is equals to 3.51. So the possible orbits will be 3, right? So here the possible orbits is 3. So we can write that here possible orbits n is equals to 3, right? So here there are 3 possibilities. See here, this is n is equals to 3, n is equals to 1, sorry, n is equals to 2, and at last n is equals to 1. Here in n is equals to 3, the energy is 1.51 eV. For n is equals to 2, the energy is 3.4 eV, and for n is equals to 1, the energy is minus 13.6 eV, right? We already studied about this. Now here there are three possibilities. Which three? So here first of all, the transition from n is equals to 3 to n is equals to 1. So here see direct from n is equals to 3 to n is equals to 1, like this. So here in this, the wavelength of beta line is emitted in the Lyman series because n is equals to 1, right? So here in transition from n is equals to 3 to n is equals to 1, the wavelength of beta line emitted in the Lyman series, right? Now again, second, transition from 3 to 2, like this. Transition from 3 to 2, like this. So in transition from n is equals to 3 to n is equals to 2, we get wavelength of alpha line, right? And n is equals to 2, so in Balmer series, right? Now last case, from n is equals to 2 to n is equals to 1, so we get a wavelength of alpha line, right, in Lyman series, right? So here in the three cases we have to find out the value of lambda, right? So here we first of all find out the wavelength of first case from n is equals to 3 to n is equals to 1. So in transition from n is equals to 3 to n is equals to 1, the wavelength of beta line emitted in Lyman series, right? So here the transition from n is equals to 3 to n is equals to 1. So to find out the value of wavelength, we know the formula E is equals to Hc by lambda. So we can use lambda is equals to Hc by V. So lambda is equals to Hc by E. So here the transition from 3 to 1, so we denoted lambda 3 1 is equals to Hc upon E, but the change in energy E1 minus E3, right? Because here the transition from n is equals to 3 to n is equals to 1, right? Okay. Now we know the value of H 6.625 into 10 raised to minus 34, value of C 3 into 10 raised to 8 upon value of E1 minus 13.6 minus value of E3, see here, minus 1.51, right? So we get lambda 31 is equals to, here we get 19.87 into 10 raised to minus 26 divided by 12.09. Here this is in EV, we have to convert into joule, so 1.6 into 10 raised to minus 90, right? So we get lambda 31 is equals to 1.03 into 10 raised to minus 7 meter, right? Again here there are three cases, from n is equals to 3 to 1, then 3 to 2, and last 2 to 1. So here in transition from n is equals to 3 to n is equals to 1, the wavelength of beta line emitted in Lyman series, right? So we get lambda 31 is equals to Hc upon E1 minus E3. Right? We know the value of E1 minus 13.6, E3 minus 1.51. So we get lambda 31 1.03 into 10 raised to minus 7. Now in transition from 3 to 2. So in transition from n is equals to 3 to n is equals to 2, wavelength of alpha line emitted in the Balmer series. Right? So from n is equals to 3 to n is equals to 2, so we can write that lambda 32 is equals to Hc upon E2 minus E3. So value of H 6.625 into 10 raised to minus 34. Value of C 3 into 10 raised to 8. Value of E2, see here, value of E2 minus 3.4 and E3 minus 1.51. So minus 3.4 minus 1.51. Again, this is in AV. We have to convert this into joule. So we get lambda 32 is equals to 19.87 into 10 raised to minus 26 divided by 1.89. First of all, this is in EV, we have to convert into joule. So 1.6 into 10 raised to minus 19. So we get 6.6 into 10 raised to minus 7. So 6.6 into 10 raised to minus 7 meter. So we get value of lambda 32 is equals to 6.6 into 10 raised to minus 7. Again, this case in transition from 3 to 2. So we get alpha line, right? So this is in Balmer series because n is equals to 2. So here lambda 32 is equals to Hc upon E2 minus E3. So we put the value of Hc, E2 and E3. This is in EV, we have to convert into joule. So 1.89 into 10, 1.6 into 10 raised to minus 19. So we get lambda 32 is equals to 6.6 into 10 raised to minus 7 meter. Now in transition from n is equals to 2 to 1. So in transition from n is equals to 2 to n is equals to 1, the wavelength of alpha line, right, because change is 1, f2 then beta line. So here wavelength of alpha line emitted in here n is equals to 1, so Lyman series. So here the transition from n is equals to 2 to n is equals to 1. So to find out lambda wavelength, lambda 21 is equals to Hc upon E1 minus E2. So value of H 6.625 into 10 raised to minus 34. Value of C 3 into 10 raised to 8 upon, we know the value of E1 minus 13.6 minus value of E2 minus 3.4. Again friends, this is in electron volt, we have to convert into joule. So lambda 21 is equals to 19.87 into 10 raised to minus 26 divided by, this is 10.2. We have to convert EV into joule, so 1.6 into 10 raised to minus 19. So we get lambda 21 is equals to 1.22 into 10 raised to minus 7 meter, right? So lambda 21 is equals to 1.22 into 10 raised to -7 meter. Okay, thank you.